everyone, I welcome you all as a part of this video lecture series where we are going to talk about different pointers on the data side. Our starting point would be managing data on AWS, where we will be discussing on storage and databases. Then we are going to deep dive into S3 for DS workflows. We will be talking about folders, versioning, lifecycle policies. Then we are going to query the data directly with Athena using SQL on S3. We will be planning a discussion on using RDS and Redshift for structured data. We are going to talk about hands-on, where we are going to store the CSV in S3, query with Athena, and then load into Pandas. And finally, we are going to conclude this video lecture series with a message: data scientists can learn to manage and query data sets at scale in AWS. So let's start with our first pointer or first statement: managing data on AWS. So whenever we talk about managing data on AWS, what does it involve? It involves choosing and integrating right combination of storage and database services to meet your performance, scalability, cost, and compliance need. So we are going to talk about data storage on AWS and databases on AWS. I've also taken few AWS documentations for you because I feel the best way to explore any feature, any service is the service documentation. So let me take you all to my first documentation called Cloud Storage on AWS. Now, best part about cloud storage is you will be getting storage as per your need. If you are looking for storing any type of data, any amount of data, or data in its raw format or native format, you have a storage option available. On the other side, if you are thinking from storing the data on the hard disk on servers, you have the options available. So based on the choice of workload, based on the nature of work you are doing, you have different options available. And few keywords which you can add with cloud storage on AWS are reliable, scalable, and secure storage for your data. Although security is the mutual responsibility of the cloud provider and customer. Okay, there would be few things which you have to take care about, that is also known as security in the cloud. Means whatever you are bringing in the cloud, that is your area of responsibility. On the other side, cloud is responsible for the security of the cloud. Okay, so now the major thing I just want to help you out with: why cloud storage on AWS? What is the reason behind it? So major reason behind using cloud computing and its feature is being agile and reduce time to market. Means you want to accelerate innovation. You want to choose from a broad portfolio of storage solution with deep functionality for storing, accessing, protecting, and analyzing your data. So if I talk about the benefits of cloud storage on AWS, these are the benefits listed in front of you. Means you can access the storage you need faster, you can reduce the storage spend, you can secure and protect your data, you can fuel innovation with new insights, and you can also build a data foundation for generative AI. Obviously, you can expand these benefits in order to get a deep dive into what exactly these benefits means. Okay, or at a very high level, if I have to sum it up all the benefits in one liner, I can say that AWS as a cloud provider provides you unlimited storage with the cost effective storage options. Okay, and also on top of it, even based on your access pattern, you can store your data in different storage classes, which is going to help you out to save the cost. Now, if I have to talk about AWS storage services, you can see if I'm going from the count perspective, they have listed 11 storage services in front of you. So from here, one thing which you can keep in your mind is a broad range of services which AWS offers as a cloud provider. Okay, they've listed down simple storage service, then EFS, FSX, and many more. What we are going to talk about in this particular discussion, I'm going to categorize cloud storage into three different ways. The first one is S3, which is known as Object Storage Service. Don't worry, I will be giving you an idea what does that mean. Then I'm going to talk about EFS, which gives you file storage service, and EBS, which gives you block level storage. Okay, so let's start with object storage. From here, we had got an understanding that AWS offers multiple storage options and each option is optimized for different use cases. Okay. Now, I told you I'm going to divide my storage choices into three categories: object, file, and block. Okay. When we talk about object storage, what do you mean by that? Object storage means you are storing the data in form of objects, or you are storing the data in its raw format or native format or in whatever format it is. So S3 suits well in that category because S3 allow you to store unlimited amount of data in its native format. You can retrieve any amount of data from anywhere. If I talk about the use cases with respect to the object storage, the use cases comes into picture. Let's say data lakes, a single source of truth, or a centralized repository with any type of data or any format of data. Okay. You can use it for the website hosting. You can use it for the unlimited storage. You can use it for the backups and many more use cases. Okay. If I give you some key features, you can say that S3 offers you virtually unlimited scalability. And there are many more features of S3 which includes versioning, lifecycle policies, cross-region replication, and many more. Few of the features we are going to cover in our upcoming video lecture. And you won't believe all these features and many more which I have not even discussed here that makes S3 a powerful service or a power pack service. Okay. If you will be exploring services under machine learning categories or data science categories or data analytics categories, S3 would be widely used because the statement which says that you can store the data in any format makes S3 as a best choice for data science. If I'm going to talk about the next option, that is a file storage. We have different categorization under file storage like EFS and FSX. First thing, why we need a file storage, let me help you out. So here, when we want to share the data across multiple instances deployed in multiple locations or multiple availability zone, I can make use of EFS. So here we are using EFS in order to share the data. So it is ideal for shared access by multiple instances and applications. Okay. Now, one thing, EFS is suitable for Linux-based workload. I will not be going deep dive into infra part, but at least you should be having a basic understanding on infra too. Okay. And how can I give you a basic understanding? I always believe that servers are everywhere. Means if I have to define infrastructure in IT, I always define infrastructure in form of servers, everybody. Okay. And when servers would be coming into picture, like you can call servers as machines, you would be having operating system running on top of those servers. Let's say Windows or Linux or Mac or many more operating system. Now, I had given you one categorization that for Linux-based workloads, EFS is a choice. But what about if we have different types of workloads other than Linux? For example, Windows-based workloads only. Okay, how I'm going to share the data across different Windows machines? The answer is we will be using FSX. Now, FSX is a service. It comes with different categories. Like FSX for Windows is suitable for Windows machines. Okay. And then comes block storage, which is here, EBS. What do you mean by block storage? Block storage means you are storing your data in the blocks of equal size. The best example to understand this, all of you would be aware about hard disk on your laptop, on your machines. Okay. Now, in the hard disk, suppose if your laptop is having a specification 1 terabyte of hard disk or 2 terabyte of hard disk, you do the partitioning like C drive, D drive, E drive, F drive, and you are storing your data in those partitions. Okay. So here the point is we store the data in chunks. We store the data in blocks of equal sizes. Okay. So these are the three main categorization under storage. Yes, we have many more, like you can even see here as a part of the list. Okay. But for the time being, to start a journey with, we have to understand these three. Okay. And if sometimes a doubt comes to your mind, a very common question which my students ask to me, what is the difference between object storage, block storage, and file storage? Very good AWS documentation is available. Let me help you out. So let's say object versus block versus file storage. And you can specifically type AWS. See here, very good difference has been given to you. What is the difference between block, object, and file storage? There are three ways of storing data in the cloud so that users and applications can access it remotely over a network connection. Now you can see the difference. Block storage takes any data like a file or database entry and divides it into blocks of equal sizes. Object storage stores and manages all the data in unstructured format and in units called object. And if I'm talking about cloud file storage, it basically provides servers and applications access to data through shared file systems. Okay. Obviously, if anybody is interested, you can read more about these three features, like what are the similarities, how do object storage, block storage, and file storage work, what are the key differences. Okay. If you want to go into more technical side, and when should one use object storage, block storage, and file storage, this option also they have given to you. Okay. You can read from here. Finally, summary of differences between object versus block versus file. Okay. So that was about storage on AWS. Now it comes to databases, or we are going to talk about databases. Okay. Now, what do you mean by databases? If that is a question I'm going to ask to all of you, maybe I'm going to get a definition. Database is the collection of data stored in rows and columns in a tabular form. It's very common. That's a very common definition we used to hear from our school days. Okay. And we used to feel this definition as a right definition all the time. But let me make this very clear to all of you. These days, in the current trend, we are not only dealing with structured data. We are not only dealing with data stored in rows and columns in a tabular form. Instead, we can deal with any type of data or any kind of data coming from any of the data source. Okay. So in a similar manner, if you have to talk about databases, you can simply say databases are used to organize, query, and manage data efficiently. Now, why AWS databases? The first thing about AWS databases is most of the administrative tasks will be taken care by AWS based on the choice of service you're making. Okay. And then databases offers a high performance, secure, and reliable foundation to power generative AI solutions. Okay. So these days, when we are talking about, or when we are living in the world of generating AI, we are also looking towards the services like from the generative AI point of view. Okay. But other than generative AI, these services can help you out with different features. And these are widely used in the industry even before generative AI or recent generative AI, I can say that. Okay. So best part, what I like about this document, apart from benefits and databases, if you will scroll down, they are talking about many more things. Okay. And these are the database services. Now, this table is very useful for the candidates who are not aware about different type of databases. Okay. Now, obviously, this would not be an exam question. Okay. But the idea is there are different categories which has been used in order to divide AWS services like relational, key value, in-memory, document, and graph. and even white column and time series. Okay. And they have given you, first of all, what are these database types. So if somebody is new, if somebody wants to get a basic understanding, don't want to get a deep dive into, they can refer this particular article. Okay. Then we are talking about the use cases for each database type and what are the services supports these use cases, or what are the services supported by these database types. Okay. Anything you can say. The major categorization of databases, like we can do, that is relational and non-relational. Relational means where the schema or the structure is defined. Non-relational means where the structure or schema is not defined. Okay. Now, as a part of our videos lecture series, this particular video lecture series, we will be talking about RDS and Redshift, the two major database categories. Okay. So you can see from here, like what do you mean by relational? Relational databases are having predefined schema and relationship between the data. Okay. Key value, these are very commonly optimized for the storing and retrieving large amount of data. Okay. So here the power is database delivers quick response time even in extreme volumes, okay, of concurrent request. In memory means you want to reduce the overhead, you want to reduce the burden on the master database or main database by providing the data or by responding to the queries from the memory. Okay, so they are used for the applications that require real-time access to data. In a similar manner, we have document, graph, and other database types. Okay. Now, before I'm going to conclude this particular video lecture, let me ask you what are the key takeaways, okay, from our discussion till now. So, key takeaways means storage service you can assume where and how you keep your stuff. Databases, you can say how you structure and retrieve that stuff efficiently. Means, first of all, you're storing somewhere in the storage service. Then you are basically defining a structure. You are retrieving the data efficiently. Okay. So if you're going to compare with the real life, in the real life, you won't store tax records in your backpack or keep thousands of books on a whiteboard. Each service fits a specific role. And when you are going to explore a particular service category, you will be able to understand the major benefits these services leverages. Okay. Now, I also want to discuss about one last question with all of you. Okay. My last question is, what is the difference between storage and databases? Very important question. Okay. Can storage act as a databases? So answer to this question whenever I have to talk about, see, actually, you can provide lot of distinctions. You can provide some similarities in storage and databases. One very simple answer which I always give, that is storage are used for long-term storage. Databases are used for performing day-to-day queries or day-to-day operations or daily activities. Okay. So storage purpose is to store, retrieve raw data. And database purpose is to organize and query and manage data efficiently. Okay. Then another difference can come with respect to the data type. So storage options which we have seen, these storage options support structured, unstructured and semi-structured data. Okay. In databases, structured data is stored in tabular form in rows and columns. If we are talking about semi-structured, we store the data in key value and JSON format. Okay. So on the same line, there can be many differences between storage and databases, but yes, you can use both of them together. As I had given one example to all of you, I'm going to give it again. So, like in your real life, you would not store tax records in your backpack or keep thousands of books on a whiteboard. Each service fits a specific role. Okay. So, if there are similarities, understand the similarities, but on the other side, don't deny the differences among different AWS services. And that is a reason they have been designed for different use cases. Okay. So I will be keeping my this particular video discussion till here, and I am going to see you all in the next video lecture. Till that time, thank you very much for watching this video. So in this video lecture, we are going to talk about deep dive into S3 for data science workflows. We will be covering different concepts here that includes folders, versioning, and lifecycle policies. I have taken a blog for all of you, and I am also going to help you out with the help of some diagrams. Now, first question which comes to our mind, why S3 is central to data science workflows. Like whenever we are exploring AWS, why we want to talk about S3 all the time. Okay, so S3 is a data lake backbone. Whenever we talk about data lake, we can call data lake as a single source of truth, or we can call data lake as a centralized repository where we are storing data in its native form or raw form. Okay. Now, S3 being a powerful service or cost-effective storage option, it gives you durability, means chances of data loss is minimal. As AWS creates the copies of object in multiple availability zone, obviously there is one exception as per the storage class. Okay. It is scalable and integrates tightly with the AWS services and machine learning tools. So if I have to talk about some use cases data scientists typically use S3 for, the first one is raw data ingestion and storage. Then you have intermediate processing output. You can use S3 for model training data. You can use S3 for model artifacts like checkpoints, logs, metrics. And you can use S3 for the final reports or dashboards. It's your choice. What exactly your use cases? Okay. Now, let me first of all give you an idea from the management console. So if I'm going to take you all to the management console, this is our landing page, which is also known as console home. Means that if you have to start exploring AWS services, you need to have an active AWS account. And whenever you have to explore a specific service, you can search the name of the service in the search bar. Okay, so we had explored S3 in our past video lecture series also. We know identifier for S3 is bucket. Okay, you can relate bucket as a container or a repository where you are storing your data. And data is stored in S3 in form of object. Each object is characterized by three things. One is data, another is metadata, and third one is object key. Okay, means actual content, then the info about that content, and finally the object key as an identifier. Now, can you see here that we have different types of S3 buckets like general purpose bucket, directory bucket, table bucket, vector bucket. These are different categorization. One way to understand is you can ask your queries to Amazon Q. So this is Amazon Q, an AI assistant. And what I'm going to ask to Amazon Q, I'm going to ask like differentiate among different S3 bucket types. Okay, so see here, what is the reply we are going to get? So I'm writing differentiate among different S3 bucket types. Okay, so what Amazon Q does? Amazon Q browse the AWS documentations. Okay, it is going to browse the blogs and the info, whatever it finds relevant, and then it is going to provide you the answer or the response to your queries you're asking here. Now, every service or every navigation tab will be having Amazon Q integrated. You're going to say it. You can see they're talking about there are two main categorizations, bucket types and storage classes. Under bucket, you have different types. Okay, we have general purpose bucket, then we have directory bucket, then we have table bucket. This is new. And similarly, we have vector bucket. Now you can see this vector buckets is designed for AI ML vector data storage. It is optimized for vectors, embeddings, and similarity search. In a similar manner, if you're talking about table bucket, it is specialized for structured data sources and it is optimized for tabular data format. If you're talking about directory bucket, it is optimized for high performance workloads. And general purpose is the original and most common S3 bucket type. Now, anybody of you, if you want to relate it with real world analogies, you can see this particular block. Here, I have explained bucket types, not just storage, but I have explained the hidden logic behind bucket type. So I have said general purpose bucket all in one container, and then I have taken the pointers about it. In a similar manner, directory bucket is an organized closet. So basically, I have used analogies, different analogies here. Okay. Table bucket, it's a spreadsheet in the cloud. And if I'm talking about vector buckets, it's a brain behind artificial intelligence. Okay. So why I'm giving you an idea about these bucket types, because based on the use case you are dealing with, you can create a bucket of a specific type. Okay. So now we are going to create one bucket and then we are going to explore different features inside that bucket. So it's your choice. Either you can create a bucket from the management console or you can create a bucket using CLI. So let me open CLI, and for that I will be using Cloud Shell. And I'm going to create a bucket today. Let me do that. So let's wait for the Cloud Shell to be loaded and the terminal to be appeared. So here the command is this: AWS S3MB, and then you have to provide the bucket name. Okay, so you can provide any name. The pattern is S3 colon double slash. Okay, so let's say I'm giving a bucket exploring DS bucket. Okay, and if you want to append date, you can append a date. For example, I'm appending a date. Okay, and press enter. If everything would be fine, this bucket would be created in your AWS account. And how can you verify this bucket? Go back to S3 dashboard. In the S3 dashboard, if you're going to refresh it, and let's say if you want to sort it on the basis of creation date, let's see that. This is the one which we have just now created, exploring DS bucket with the date. Okay. Now this DS bucket we are going to use in order to explore different behavior. Like first behavior we are going to explore, that is folder. What do you mean by folder? Okay. So although S3 is an object storage, means it follows flat structure. So here folder does not mean physical folder. Here folder we are using a keyword for prefixes. Okay. This prefixes makes the organization intuitive and helps with performance partitions pruning. Okay. A very simple idea about understanding the concept of these folders or prefixes is that, let's say I'm generating the cost allocation report or cost report every month, like for my AWS services, or even you can put a cost report on a daily basis. Okay. Let's say I'm storing this report in the S3 bucket. If I will be creating the prefixes, let's say current date, or I can create a prefix on the basis of daily date, and then I am going to upload the file into that prefix. So these folders are helping you out to create prefixes, to create partitions, so that it would be easier to retrieve the relevant data you are looking for, either over the web or either through the databases queries. Okay. You can also restrict or apply the permissions based on your need. Now I have taken this particular diagram for all of you. If you will be seeing this diagram, suppose I have a bucket called my DS project, and we have created some prefixes here, like one prefix for raw, then processed, then models, then experiments, then reports. First of all, these logical prefixes are giving you an idea, an actual overview, what exactly you are going to store and where. Let's suppose if you have some unprocessed data, a data in its native format, I will be storing the data in the raw folder or in a prefix starting with raw. Okay. So basically, if I have to retrieve the data later, like based on the logical names I have given here, I will be able to identify, I will be able to make my query faster. and I will be able to relate from which particular prefix I have to fetch the data or retrieve the data. Okay. So this was the first thing I wanted to explain as a part of a discussion. Don't worry. We are going to talk about few more things as a part of this video lecture. In short, you can track the historical changes whenever you are talking about bucket versioning. Because what's the default behavior? By default, bucket versioning is disabled. So you can enable it at the time of creating a bucket, or even you can enable it after creating the bucket. So don't worry, as I'm going to show you a demo, I will show you the differences that what happens without bucket versioning and what happens after enabling the bucket versioning. And scrolling down, you can manage the encryption. Encryption is one of the security setting in the S3 bucket. If you want to explore different advanced settings, which includes object lock, a simple keyword to understand object lock is warm. Write once and read many. Okay. But we are going to create everything default. We are going to have this bucket with the bucket name we have provided, and rest of the settings I am keeping default. Okay. So what intelligent tiering is? It is designed for data with changing or unknown access patterns. And everything comes up with a cost. Means here you can see we have a monitoring and auto tiering fee if you are going to have your data in intelligent tiering. Okay. But here you are going to get the smart assistance. Means AWS is going to monitor your object, and based on the access pattern, your object will be automatically moved. So this particular section is to choose the storage class based on your workload, based on your use case. So by default, if you are not providing any storage class while storing the objects in S3, your object is stored in standard storage class. Okay, so let's answer this question without any further delay. So if I'm saying for 30 days immediate access, what do you mean by that? It means you are going to store your object in standard storage class. Okay, let me make it bold. And if you are talking about 60 days infrequent access, you have two choices based on how you want your data to be available. Either you can move it to the infrequent access or one zone infrequent access. Let's say I'm choosing S3 standard infrequent access. Okay. Then for 180 days, you want to archive your objects. If you want to archive your objects, then Glacier is a choice. And after 365 days, you want to delete your object. It means you have to perform the delete operation. Okay. So if you are aware about the storage classes, you can take the right decision to move your objects from one storage class to another storage class whenever needed. Instead of keeping your object in a single storage class, you can leverage this feature of S3 and save the cost associated. So come back and we can upload the object using standard storage class for the time being. Let me do that. So I'm going to my Cloud Shell. You can click inside the terminal window if your Cloud Shell is asking you to reconnect. Okay. And what we will be doing, we will be using simple commands to upload the file. If you want to do a drag and drop from your local machine, you can do that too. It's your choice. So let me do one thing. I am going to upload the object. So first of all, let me list down if I have something here. Better, I can delete everything from here, and I am going to create new files. So I have used rm command first of all to delete the two files. As I had two files listed down, so I am deleting both the files in a single line. Next time when I am doing again listing in order to see what all objects are present, I'm not getting back any response. So simply let me create a simple file. For example, echo I am understanding as three features. Okay, something like this. And let's append this to a file called test.txt. It is done. If you will be executing ls again, this file is present here. Now I'm going to upload the object to S3 using a command called AWS S3 CP. CP is for copy. Provide the name of the object. I'm providing a name, and then I have to provide the name of my bucket. So take the name of the bucket from your console. So let me first of all take these forward slashes. I'm going to provide this forward slash, and then I'm going to take a bucket name. Okay, let's take this bucket name, everybody. Go back, paste it here. If you want to save the object by a different name, even you can provide the object name. Otherwise, if you're not going to provide any object name, it will be stored with a name called test.txt. Let's press enter and see upload. How can you verify? Come back to your bucket, and if you're going to refresh it, you can see the object got uploaded. Okay, now one thing all of you can see that storage class of this particular object is standard. So by default, if you are not choosing any other storage class, this object will be stored in standard storage class. Now one way to change the storage class of this object is go to actions, and here you can edit the storage class. So you can change the storage class whenever you want. But this is something you are doing manually. Means whenever you have to change the storage class as per our this requirement, you are selecting an object, you are editing a storage class and making a change. This is for single object. What about if you have so many objects stored in the S3 bucket? Are you going to change the storage class of all the object one by one? Is it an ideal way? If you think it is an ideal way, so let me tell you it's not. Then what is a solution for this particular problem? The solution is we are soon going to explore the concept of life cycle policies. So we are going to explore life cycle policies in order to move the objects automatically from one storage class to another storage class. Let me guide you. So if I am clicking on cancel button, I'm not changing the storage class for the time being. I have already shown you how to manually change the storage class. If I'm going to management part, you can see a life cycle configuration here. You can use lifecycle rules to define actions you want S3 to take during an object's lifetime, such as transitioning object to another class, archiving them, or deleting them after a specified period of time. But if you have to use life cycle policies, you also need to understand versioning. Okay, so let's see the demo of versioning first, and then we are going to create a life cycle rule. So first thing I'm going to do, I already have this object stored in S3 bucket. But if you are going to select it, copy the URL and paste it in the browser, you will be getting access denied. This is understood. Why so? I told you at the time of bucket creation, all the public access settings are blocked by default. You will not be able to access the object over the internet till the time you are providing the permissions or managing the permissions. Let's do that. Go back to your bucket, go to permission, and one way to manage the permission to the S3 is creating a bucket policy. Now what we will be doing, we need to edit this setting. So for a demo purpose, you can untick all these settings here. Means you can disable this block all public access. Or what you can do, you can only disable the settings which you have to use in order to grant the permission. For example, I am talking about bucket policy. So let me keep these two settings disabled and I am enabling other two settings. Say save changes. You have to provide a confirmation here and say confirm. Now this part is done, but we have not granted any access yet. We have only changed the setting. So how to grant the access? One way to grant the access is using bucket policy. As the name is suggesting, this is a policy you are applying at bucket level. With the help of this policy, you can control the access to the bucket as well as objects inside a bucket. So click on Add, and let's create a bucket policy. For that, we're going to use policy generator, because if you don't know how to write a JSON policy, totally fine. You have a policy generator you can make use of. So click on policy generator and let's generate a policy, everybody. So first thing, I'm going to choose S3 bucket policy. The effect is allow. Principal, I'm going to provide star. So effect means, do you want to allow or deny? Star means to everyone. Actions, you can choose what actions you want to allow. For example, right now, I am allowing get object access. So I'm choosing get object action. And now ARN comes into picture as the Amazon resource name, a unique identifier for the AWS resources. So this time I am performing an object level action. So I will be needing the ARN for the object. So one way to get the ARN for the object is you can go back to your bucket. Inside your bucket, the object you're talking about, open the object and take the ARN. This is the ARN of the object. If you want to frame it by yourself, you can see it here. Go back to policy generator. They have also given you the syntax. Okay, so choice is yours. What I am doing, I am going to take my bucket ARN because I know all the objects are present inside a bucket. Okay, so if I have to provide the object, I will be providing the object key. Okay, so one way is either you can provide a specific object key. Let's say this time my object is test.txt. Okay, but what about if you have more than one objects and you want to grant the permission for all the objects? Say star. So I have applied star. Okay, so currently I have allowed the public access from anywhere. But for the security reasons, let me add a condition or a filter. So click on add conditions. Here I'm going to add a condition. Means I am allowing the access only when the request is coming from my IP address. So choose source IP or IP here. Okay, IP address. The key would be source IP. This is a source IP. Okay, and you need to provide a value. So how you are going to check your source IP? For checking a source IP, you can type here, what is my IP address? And you will be getting your IP address which you're going to use. You have to use IPv4. Let me use it. For example, come back here, say this particular IP, and you have to provide /32 because whenever we provide the IP address, we have to specify the CIDR notation. Okay, you don't have to get into deep dive. Simply understand for the time being, /32 means single IP address. Click on add condition. Click on add statement. Click on generate policy. So your JSON policy is ready, everybody. Okay, you can copy the policy. Let's click on copy policy, or otherwise you can select it and copy it. Come back here and paste this policy here. Okay, let's say save changes. Changes are saved. I am closing this policy generator. If I'm going to refresh my browser this time, I will be getting the text inside demo.txt or test.txt. Actually, I'm understanding S3 features. Okay, now the point is you can manage your bucket policies using policy generator. You don't have to write the JSON, and I am able to access this particular object over the internet. Okay, but I'm not done yet. I had to explain you versioning, and for explaining you versioning practically, I wanted to show this part. So using this, you also had gained an understanding that how can you manage or control the permissions. So first thing, what happens by default, S3 stores only one copy of an object at a time. Means if I'm going back, and I'm going to the object. Currently, I have this test.txt, and if I am checking the content inside this, I'm understanding S3 features. Let's suppose I'm again going back to my Cloud Shell and I am editing this file. Okay, let's say I'm again using the same command, and if you have to add another line inside a file, for example, I'm writing like this, adding another line in the same file. Okay, you can use up arrow key from your keyboard if you want to execute the commands you have executed in past. Okay, press enter. Quickly check what is inside this file. So you can see now two lines got added inside this file. So what I'm doing, I'm again performing my copy operations. Let's do it. This time, if you are going to refresh, my versioning is disabled. That is true because I had not enabled versioning at the time of bucket creation. You can also ensure that by going to properties and bucket versioning is disabled. So without versioning enabled, you can see at a time only one copy of an object is present. Means the older one will be overwritten by the latest one. And even you can check this from here. You can see you only have the latest copy of the object. This is the first default behavior when the versioning is not enabled. Okay. Now what is the second default behavior, everybody? The second default behavior is if you are going to delete an object. So this delete operation or this delete action is the permanent delete action. Means your object will be permanently deleted. And there is no chance, there is no way to restore this object back. Okay. So type permanently delete and click on delete objects. Your object is gone away. You can't restore this object back. You can see. So these are the two default behaviors you have to understand before you are going to enable versioning. Because when you will be enabling versioning, it is going to help you out. Okay. So let's go to properties and let's enable versioning this time, everybody. So click on enable and save changes. So versioning is enabled. How can you ensure this? As soon as you enable versioning, you will be seeing a switch, or you can also call it as a toggle button. Okay, what this toggle button says, or what this toggle button does. So here at this particular side, you will be seeing the object, and if you are going to switch to this toggle button, you will be seeing the object versions of that specific object. Let me show you. I'm following the same, everybody. I am quickly editing this file, and this time I want to overwrite the content just to start from scratch. So I am creating a simple file by saying I am learning versioning. Everybody, you can also upload the data file in the S3 bucket. It can be a CSV file, it can be any other file of your type. This is just to make you understand the concept, and that's the reason I'm taking the txt file. Okay, let's press enter here. If you want to display the content, so this is the line I have added. Okay, a new line, or you can say that I have overwrite the existing file just to start from scratch. Okay, execute the copy command again. I'm using the up arrow key to avoid typing. Come back, and this object is uploaded. Now always remember, on this side of toggle button you have object. On this side of toggle button, you have object versions. Each object will be assigned a unique version ID. So currently, I have only one copy of this test.txt. Let's upload another copy, everybody. So same command, and this time I'm writing uploading another copy of object in S3. Okay, I'm going to append this. Before I'm going to perform copy operation, let me show you something. If I will be selecting this object taking the URL, paste it here in the browser, I will be seeing the first copy of the object. And as soon as I'm going to use this copy command, if I will be refreshing it, I will be seeing the latest copy of this object. But when you enabled versioning, what happened, everybody? You can see two copies of the object stored here, each with a unique version ID. Means unlike versioning disabled bucket, here we have multiple copies of an object or multiple variants of an object stored in the S3 bucket. Each is having a unique version ID. So now if a question comes to you that if I want to retrieve a specific version of this object, select the object version, I will be saying, copy the URL and paste the URL in the browser. Okay. Now forget about this access denied. Obviously, we're going to talk about it, or we are going to understand how to troubleshoot it. Right now, I want to tell you what is the difference between these two URLs. The difference is this version ID. If you have to retrieve or fetch an object version, that will be having a version ID in the URL. Okay. Now let's come back to access denied. So I will be helping you out to troubleshoot, and then you have to troubleshoot by yourself. See, if you have to be at any role in the industry, you have to develop good debugging skills. And how you develop good debugging skills? When you are relating the concepts. For example, whenever I talk about access, access means something related to permissions. And if I am getting access denied, it means I don't have a permission. But maybe all of you would be thinking that just now we had used policy generator to create a policy. Fine, totally agree. But what type of actions you have allowed in that policy generator or using that policy generator, that also we have to ensure. Like here, you are performing the action called get object. But here, you are performing the action called get object version. So let's see. Go to permissions and see your bucket policy. Do you have any such access called get object version? The answer is no. So let's provide it. So you may be thinking that we needed to generate a policy again using policy generator. No. You can directly provide or directly add an action here. How? On the right hand side, you are seeing an option to edit a statement. First of all, choose a service. S3 is a service, obviously. What type of actions you want to provide? Get object version. Select it. You can see it got appended here. And simply say save changes. As soon as you have done it, this time you are allowing two actions to be performed on this bucket. Let's refresh it. And you are going to get your result back, everybody. Okay. So what you have seen how can we enable versioning, how can we get the latest copy of the object, how can we get the specific version of the object. Okay, now this part would be clear to all of you. Let me put another question in front of you, because I had explained you two default behaviors when versioning is not enabled. We had seen storing multiple copies of an object. Okay, another question is, can you permanently delete an object in a versioning enabled bucket? Now listen to my question very carefully. Okay. Can you permanently delete? If I'm asking you this question very straightforward, the answer to this question is yes. So you would be thinking, then what is the difference? I am not saying that you can't permanently delete an object. I am saying if you have a versioning enabled in the bucket, you can restore the object back if you have performed a deletion action. Now, please listen to my keywords very carefully. I'm again repeating. This side is the object. This side is the object version. So you can restore the object back from the deletion only if there would be at least one copy of that object or one version of that object present. Okay, means if you have to permanently delete an object in a very simple way, Simply delete all the versions. When nothing would be left, an object will automatically be deleted. So you can perform delete action either here or here. Okay, means you can perform delete action either on object or on object version. Now, object version deletion action you can't restore. I can show you. Let me click on delete. It is saying permanently delete. Deleting the specified object can't be undone. Okay, but on the other side, if I am deleting an object in a versioning enabled bucket, this time it is saying that deleting the specified object, add a delete marker to them. It's not asking me to type permanent delete. And what this delete marker is actually, this delete marker is a configuration which is added on top of the object, okay, when you are performing a deletion action. Okay, means instead of deleting the object, S3 will mark that object deleted. So object is not deleted. So it will be adding a delete marker on top of object versions. Let me show you. See here. So for you, the object is gone, but still we have a way to restore it. Can you see? It has added delete marker on top of all these objects. Okay. And if you want to restore your object back, delete this delete marker. Everybody, let's do it and say delete. This delete marker got deleted. Okay. And you got your object back. So idea is whenever you're going to practice, you can understand that if you're performing a deletion action here, this action can be undone. Okay. But if you are performing a deletion action on object versions, this action can't be undone. Okay. So if somebody is asking you, don't get confused. Can you permanently delete an object in a versioning enabled bucket? Simply say delete all the object versions associated with that object. Okay, if somebody is asking you, can you restore the object back if you have deleted it in a versioning enabled S3 bucket? Answer is yes. So we can remove the delete markers which is added on top of all the object version. Okay, so this was the whole concept of versioning. Now, why I have explained you versioning? Because when I am going to show you creating a life cycle rule, it will be using versioning in picture. Let's see. Go to management and create a lifecycle rule. Okay. Now you can provide a lifecycle rule name. Let's say I'm providing a name demo lifecycle rule. Okay. It is giving you two radio buttons. Means you can limit the scope of this rule by applying one or more filter. You can provide prefixes. Means let's say if you only want to apply the life cycle rules to some of the object in the S3 bucket, you have 100 plus object, or you have object of different type. Some are txt, some objects are .png, jpg, html, like that. Okay, so you can use prefixes. We had already understood the concept of prefixes. Okay, if you want to apply this rule to all the objects in a bucket, select second radio button. You have to provide acknowledgement, and here you can choose the life cycle rules action. Transition current versions of object between storage classes, transition non-current versions of object between storage classes, and many more. Current means latest, non-current means previous versions. Okay, so let's say I'm transitioning the current versions of the object between storage classes, and if I have to delete the object, I'm going to delete the non-current versions of the object. Okay, so these two rules, actions I'm applying. Now, I always believe in one thing, cost comes with comfort. If you're looking for more comfort, you have to pay the charges. The same thing it is saying here. Transitions are charged per request. Okay, so I'm providing the acknowledgement. Now you can explain your behavior. For example, after 30 days, I want to move it to standard IA. After, I can say that 90 days, 30 in the standard storage, 60 in standard IA. Okay, I want to move it to Glacier instant retrieval. Okay, after 180 days, I want to move it to the Glacier flexible retrieval. Now you're seeing a hierarchy. you can go from top to down, but not from down to top. Means once I have selected Glacier Instant Retrieval, you can move the object into these classes, not on the top classes. Okay. And here I'm writing that I want to permanently delete non-current versions of object after 365 days. It is asking me how many newer versions you want to retain. So if you only have to retain the latest copy, so say only one. Okay. Now see this hierarchy. Day 0 object uploaded. Day 30 object moved to standard IA. Day 90 object moved to Glacier instant retrieval. Day 180 object moved to Glacier flexible retrieval. And finally, if I'm talking about deletion behavior, day 0 object becomes non-current and day 365 one newest non-current versions are retained. Okay. We can also compare it with the pointers I had written. For 30 days, immediate access. For 60 days, infrequent access. For 180 days, archive object. And after 365 days, delete your object. Now, this is not a standard. It was just an example. Obviously, you can decide your examples by yourself. Okay. So going back, if you are going to click on create rule, you will be able to see in picture that this rule will be coming into the picture automatically. Okay. And the objects will be transitioned from one storage class to another storage class as a part of the rules you have set. Also, object will become non-current or object will be expired after a certain duration. So click on create rule, everybody, and you will be seeing this rule here. So this is something I wanted to show you as a part of this particular video lecture. Okay. So what we have concluded here? We have concluded that we want to understand different features of S3 and we talked about life cycle rules, versioning and folders. Okay. We're not done yet. Don't worry. We are going to discuss many more pointers as a part of this video lecture series. Let's continue our journey on querying data directly with Athena, SQL on S3. So I have a lot more to share with all of you and let's learn that in the interactive manner. So first of all, I am going to use certain terminologies as a part of my upcoming discussion. So that's the reason I have taken all these terminologies here. So we are going to gain an understanding and then we will be moving towards our demonstration. So let's start with the first one. What is data catalog? So if you are going to see this statement anywhere, or if you are going to see this terminology anywhere, you can say that data catalog is a central metadata repository. Means it stores information about your data, not the data itself. Data will be present in the data store or actual data will be present in the data store. Data catalog will be storing the data definition. Okay. Next service, which is a major service we are going to discuss, that is Amazon Athena. What Athena is? A very popular, a very famous service with respect to the data analytics track. So it is a serverless interactive query service that lets you use standard SQL to analyze data directly in Amazon S3. Means you no need to move or load the data anywhere. You can directly query the data from the S3 bucket. So from here, you can say that your data is actually present in the S3. You are using Athena in order to query that data. But how we query that data, soon we are going to understand and learn that. Okay. It uses Presto, Trino under the hood and integrates with AWS Glue Data Catalog for schema management. Now, what is this particular term? So maybe if you have already worked on this term, you will be aware that it is a distributed SQL query engine and it is specifically designed for big data analytics, everybody. So I have already taken this terminology also for all of you. And the last one, which I will be discussing as a part of this particular discussion right now. I'm not done yet. I have a lot more to share with all of you as I had mentioned this in the starting only. Glue. Glue is a fully managed serverless data integration service that helps you discover your data, prepare and transform it, and load it into data stores. Means if you have to give one keyword for all these services, data catalog is a centralized metadata repository. Amazon Athena is the serverless interactive query service. AWS Glue is a fully managed data integration service. It is majorly used to design pipelines. And how we are going to use this service as a part of our demo, I'm soon going to help you out with that. So basically, I have planned a demo for all of you in different ways. We are going to execute a direct queries. We are going to understand few features of AWS Glue, and we are also going to explore the Python code. Okay. So first thing, let me help you out with this particular diagram. What exactly is happening from where we are starting? We know S3 act as a single source of truth, or S3 act as a data lake where you can store your data in a raw format, in native format, in any format. Okay, so here S3 is the location or a data store where your actual data is present. When you are using Athena, okay, or when you are using Amazon Athena console, what exactly you are doing? You are running the SQL queries from the Amazon Athena, and this glue data catalog is storing the schemas or the table definition. Okay, so this is exactly what is happening. Athena is referring the schema definition from the glue data catalog, which is pointing to the data present in the S3 bucket. So actual storage location is S3, and then other services we are using for the data definition and querying it. Okay, let's start with a very simple demonstration first, and then later I am going to take you through certain differences which I have taken for all of you. Means what can be different Athena scenarios? When glue is not used with Athena, what are the differences? And finally, the use cases where you can use different combinations or different scenarios of Athena. Okay, so let's start with the first demo, everybody. What is the first demo we are going to do? We are going to create a S3 bucket and we will be storing our data into S3 bucket. Let me help you out with that. So without any further delay, let's go to the AWS management console. Okay. Let me close the additional tabs and I will be starting from here. Okay. So if you are starting for the first time and if you have already watched my previous video lectures, my starting point is console home. So search for S3 in the search bar and you will be navigated to the S3 dashboard. Now from the S3 dashboard, what we are going to do? Our demonstration will be started with creating a S3 bucket. So click on create bucket, everybody. And I am going to create a general purpose bucket. We have already got a very good understanding on bucket types, on different features of Amazon S3 as a part of our previous video lectures. Okay, just give a globally unique namespace. So for example, I'm giving a name Athena demo DS bucket, something like this. Okay, we can check if this bucket is existing or not. If this bucket would be existing, we will be appending some unique keywords at the end. Okay, rest all things with respect to block public access setting, I'm keeping default because anyhow I am going to follow these steps in the same geographical location. So scroll down and say create bucket. Your bucket would be created. Let's wait for the bucket to be created, everybody. So this is my Athena demo DS bucket. Now I am going to create a prefix here for the better management, okay, or for making the search and filtration easy. So click on create folder and let's say I'm going to give a name called sales data because I'm going to use a sample sales CSV file. Click on create folder. Now, I had already explained to all of you, this create folder is going to create a prefix, is going to create a partitions, which can be used in order to manage, to filter your data easily, and which is going to improve the performance at some point of time. Okay. Now, I would be using a simple CSV file. I can just show you. Let's say I will be using the sales data.csv. This sales data.csv is containing all these information. And I have other file also, like this is sales.csv. Okay, so any sample data we can use it search wise. Okay, let me start with one of the CSV file. So I am going to upload this CSV file into the S3 bucket. Now we have already discussed that we can also use command line interface, management console, or programming interface to interact with AWS services. And don't worry, I will be giving you the exposure to all the interfaces as a part of the demonstration. Okay, so let's quickly upload the data inside this particular folder. Okay, so you can do a drag and drop or you can browse for the file. Let me do a drag and drop, everybody. Let's say I'm dragging this and dropping it here. It's going to upload a CSV file. So CSV file is uploaded here. Means first part is done. I have a S3 bucket. I have a sample data available in the S3 bucket. Now, obviously, for a demo purpose, I have taken a small data set. You can have a large data set you can take. And just to give you exposure, actually, I'm going to take one more data set going forward. This is the one. If you want data set with more attributes, I can also provide you a link. Like you can see, it is having 266 records. Okay. I've also taken this link, everybody. You can use this particular website, and there are many, from where you can download the sample data set. You can use Kaggle also to download the sample data set. Choice is yours. Now go back and let me take you all to Athena. I will be opening this Athena dashboard, and we are going to talk about Athena a little bit, although I have given you an idea. Start querying data instantly. Amazon Athena is an interactive query service that makes it easy to analyze data in S3 and other federated data sources using a standard SQL. What is this federation? What is this federated data source actually? So Athena provides you advanced feature, means usually whenever we talk about Athena, a common statement which comes to the mind that you are querying the data directly present in the S3 bucket without moving the data. Okay. But you can have a data present in other data stores. How can we query that data using Athena? There comes the concept of federated queries or Athena federated queries, everybody. Okay. So it was just for the understanding purpose. If you want to explore more things like how it works, you point to your data source, register and select any data source, and then you can do querying, or you can start querying and analyze the result. These are the benefits. Then you have the use cases like query AWS service logs, query from any data source, ETL data into S3 data lake, and model training and invoking machine learning models. These are the benefits. And also they have given you two ways. Either you can query your data with SQL, or you can analyze your data using PySpark and Spark SQL. Okay. So I'm going to launch a query editor as a part of the first demonstration. And when you're going to launch a query editor, what we have to do? For a simplicity, what I will be doing, I will be removing any external table and databases created already. Okay. So currently, if you're coming here, you are seeing a database and a table. This database and table, it is picking up from AWS Glue. Means the definition will be created in AWS Glue. Let me show you here. It's here. Let me delete it, everybody, and say delete. Okay. Let me also check if I have any table present. No table present. Come back and you can see nothing is selected. Now, first thing or first change all of you have to make, you have to go to settings, everybody. If you are coming to this Athena dashboard for the first time, you have to change this query result location. For example, in my case, what I would be doing, I would be using a same bucket and I'm going to store the query results in the same bucket, everybody. So go back here and say manage, say browse. Okay, I'm going to browse this bucket. Let me select it. Let's choose it. And I am going to add a prefix in the location of query result called query results. It's optional. I'm using it in order to manage the things better. Let's save the changes, everybody. Once the changes are saved, come back to the editor section, and here we are going to execute some queries. So let's start with our first query called create database. Let's use this, and we are going to execute create database query. You can see a demo DB got created. And for your knowledge, if you will be going to a databases, a demo DB got created here. Means schema definition will be stored in glue data catalog. Now next thing, what I will be doing, I will be creating a table. Now you can either create a table from the data source called S3 bucket data like this, or if you want to execute a query directly, you can write a create table query. So we are going to create the external table, and all these are attributes which we have given, which involves the mapping of the columns available in our data set, and then we are using few more attributes. So let me first of all provide the location of my actual data. So my data is present here. What I can do, come back here and you can take this location. You have to change this location here. So my data is present in this location. Okay, and rest all things I'm keeping default. So one thing, when I am saying table, external table, I am not storing the data anywhere in the Athena. I'm only pointing to the data which is present in the S3 bucket. And for your understanding, I have taken few things. If you are new towards it, what is raw format serving? So raw format tells Athena how to read and write the data in your table. And this stands for serializer and deserializer. It's a piece of code that deserializes raw data from storage into rows and columns in Athena. Okay, so that Athena can understand it. Serializes query result back into the output format if writing data. Okay, so it is basically a translator between raw file and table structure. And I have used a specific type, that is this one, lazy simple. So this lazy simple, it is a built-in serializer and deserializer in Hive. It is used for text-based files like CSV, TSV, or delimited text. So lazy means it will only parses the column you actually access. Okay. So as we have a CSV data, everybody, I would be using this one. So let me come back here and let me execute this query and see what happens. So if everything would be fine, the table creation would be completed. You can see. And if you will go back to the glue, you can see a table got created here. Now you would be having so many questions in your mind, like do we have to learn this syntax, or how can we write this syntax automatically? Is there any other way in order to define the table definition without executing the queries in Athena? We have. And don't worry, I am going to discuss all these ways or maximum possible ways with all of you. But remember one thing, things will come by practice. And as you're going to practice, you're going to get the things. And now let's see, if I am going to execute my first simple query, let's say I want to preview the table. You can see the query result. Now, can you see something here? Like by default, it is taking your first row as a header, means it is printing headers in your first row. How can we avoid it? So for that, I have taken few things for all of you. So basically, we needed to set the table properties. The table property we have to set in order to skip the header line count, which is the first line in your CSV file. So either you can create a table with this table property, you could do it in the start, but I just wanted to show you this error and I wanted to show you the significance of this table properties. That's why I have taken it later. We can do it. Let's alter a table, go back here and execute these commands. Okay, so once it will be executed, if this time you're going to execute your select query, let's see what is the result you're going to get. So you don't have that header present in the first row, everybody. You are getting the clean records which are available in your CSV file. Now, if you want to practice more queries, I have taken more queries for all of you. Okay, let's say if you want to view all the records, if you want to limit the results, let me take it. Let me take all of the queries and we are going to execute these queries one by one. So the first one is for viewing all the records. Let me execute this one and you are going to get the result. This is a result to view all the records. Okay. If you have to limit the result, you can apply limit keyword. Okay. So I'm not executing it because anyhow I have only couple of records available in my CSV file. If you have to view the unique categories at that point of time, you can use this attribute called distinct. And let's see the result. This is a result we're having. Okay. If you want to count the total records, you can count the total records from here. So going to get the total records count, everybody, if you scroll down. Okay. In a similar manner, you can execute many queries. I'm not executing all the queries, but giving you a quick overview. Like my another category is data aggregation, where you can do or where you can have a total revenue, total sales per category, average price per product, number of orders per category. And then I have also taken some date-based queries. Let's say if you want to have a total daily sales. Let's see that. So this is a result you're going to get. Okay. So I have given you the hint, but you can execute many more such queries. Now, before I am going to move towards the next part, let me set a question in front of you so that you can think about like why I am bringing the next part in front of you. So see here, what happens if I'm saying that you have to read the data from S3 while creating a table definition in Athena. In case of multiple attributes, hundreds of attributes or thousands of attributes, are you going to write a create table statement with one by one each and every attribute you are defining and mapping it to a particular data type? Okay. So here how you have to start, like what are the best practices. You have to understand your data in S3 and then you need to automatically infer the schema. So if you have thousands of columns, manual definition is impractical or not ideal. So you can make use of glue crawlers which can infer the schema automatically from the data stores, or you can also infer the schema programmatically using Python and Pandas. Okay, so I am going to show you both the features as a part of this particular demonstration. But think about this question and come back with the answer if you have any better way in order to deal with this situation. Obviously, you will be having a better way. Anyhow, you're engineers, so you can think in this direction and you can come up with more better ways. But my idea is to show you, is to give you an opportunity to explore different AWS features. So we are going to talk about that. Hello everyone, welcome back. So now what is the next step we are going to perform? So if you recall what we had done, we had understood what Amazon Athena is and we had queried the data present in the S3 bucket directly using Amazon Athena. As I told you, I'm going to help you out with the two more ways in order to do this task. Let's move towards our second way. Get an idea like what we had done. So I'm quickly taking you all to the Athena dashboard and let's collect the points what we had done in the past. So in the Athena dashboard, the first thing we had done in the settings, we had provided the query result location. And then after going to editor, we had created a database and we had created a table. Okay. Once the table got created, which is pointing to the data present in the S3 bucket, we started executing our queries and we started talking about some table properties. Okay. I told you that all these databases and tables are going to be stored in Glue or are going to be actually created as a part of the Glue catalog. You can see here. If I'm going to Glue databases, this is the one which we had created. And if you will go inside this DB, this sales data is the name of the table we had created. Okay. You can also compare it from here. Everybody. This is the name of the table. Now, this is obviously an external table, means it's not holding your actual data. Your actual data is still present in the S3 bucket. Okay. So this thing we had done using create external table SQL command. What if I'm asking you that you don't have to create the table explicitly here? Suppose you are dealing with a huge data set, a data set with having many attributes, hundreds of attributes or thousands of attributes. What you are going to do? Are you going to manually define all the attributes here? No, that's not an ideal way. That's not a good idea. In that case, you have to explore AWS Glue. In Glue, we have a feature called Glue Crawler. That Glue Crawler is going to infer the schema by crawling the data source. That is the thing we are going to see as a part of this particular demonstration. So let's keep this table active. Okay, we will be using a same database, but we are going to create another table using Glue Crawler. And whenever I'm using a word creating a table, actually we are creating a table definition. We are creating the table schema. Okay. Or we are creating a data schema. Anything you can say. Now, idea is if anybody wants to get a quick overview on Glue, you can see it from here. Serverless data integration. Move data sets of nearly any size and prepare them for analytics and machine learning. Glue has data integration tools for every skill set and manages all the infrastructure, remember. Okay. So now let me help you out to show this demonstration. So first thing first, we have to create an IAM role. So basically, IAM is the foundation of security in the AWS, all of you know. It is used for managing the permissions, means authentication and authorization. And if two services in the AWS wants to interact with each other, you can provide or enable the secure interaction with the help of IAM role. Like here, obviously, Glue has to perform certain actions in this account. Glue has to interact with S3 bucket or Glue has to perform other actions. Okay. So we will be needing an IAM role for Glue. So let's create a role with the basic permissions. Go to roles, everybody, and click on create role. Now, from these choices also, you can understand what are the use cases. For example, right now, I am talking about this one, AWS service. Allows AWS services like EC2, Lambda, or others to perform actions in this account. Now, for which specific service I am going to create a role, the answer to this is Glue. So select Glue here. Okay. Click on next button. And from here, you can choose a permission policy. Let's say I will be providing the first permission policy as S3 read. After this, I will be providing another policy called Glue service role. Let's check that. Okay. We have a AWS Glue service role. These are the managed permissions which we can provide. Okay. Or these are the AWS managed permissions or AWS managed policies which will be managed by AWS. Everybody. Scroll down, go to next and give a role name. Let's say exploring Glue and Athena. Anything you can give a role name. Obviously, when you're going to work in the industry, there would be some conventions which you have to follow. After providing this role name, scroll down, and what you have to do, click on create role. So your IAM role is ready. Now where we are going to use this role, we will be using this role while we are going to create a crawler in Glue. Okay. So click on view role and you are going to see the role here along with the permission policies you have provided. Okay. Now next step is switch back to the Glue dashboard, and in the Glue dashboard, I'm going to use crawlers. Okay. So currently I have some crawlers in my dashboard. That is totally fine. If you want, I can delete all these crawlers right away. Click on delete crawlers and delete. Okay. Now, if you want to recap the statement I have presented to all of you about crawler, it is a crawler connects to a data store, progresses through a prioritized list of classifier to determine the schema for your data, and creates a metadata table in your data catalog. That is my requirement. I want to create a table definition, everybody. That is something I'm looking for. Okay. So click on create crawler. Give a name of your choice. Let's say demo glue crawler, something like this. Okay. If you want to provide a description, you can. Next, you have to add a data source or data store, means from where you want to crawl the data, like which data you want to understand in order to give you a metadata or schema definition. So click on add a data source. S3 is selected. There are other data sources you can add. I am using S3 for this demonstration. Then I have to browse for my bucket. So I'm just taking this bucket name, everybody. I will be coming back. Click on browse S3, browse for my bucket, open this bucket and select the sales data. Okay, because we have our file or our data set present inside this prefix. Click on choose. Don't worry about this error, it will go away. It is telling you all folders and files contained in the S3 path are crawled. For example, if you're typing like this, to crawl all the object in my folder within my bucket, and that is something I'm looking for. Okay, I want to crawl everything present inside this prefix. Okay, say add S3 data source. Once it is added, go to next, everybody. You have to choose an IAM role here. So which role you're going to choose? The one which you have just now created. Now see, based on the role you create for a service, the role will be visible here. Let's say if I have created a role for Glue, so that roles only will be visible in the Glue dashboard, everybody. So this is my role, exploring Glue and Athena role. And go to next, everybody. You have to select a target database in which the table would be created. So I told you I'm going to select the same database and again say next. Click on create crawler. Okay, the crawler is created. Now for the simplicity, I'm going to run this crawler on demand, but you can also enable the event based trigger. What do you mean by event-based trigger? Means if something is happening, for example, you don't want to all the time run the crawler manually to and for the schema. You can also set up in this way whenever there will be an upload in the S3 bucket, this crawler will be triggered. This crawler is going to enforce the schema so that you can get the updated table definition. Okay, so I'm clicking on run crawler. For the time being, you can track the progress of crawler from here, or otherwise you can come out and you are going to see the crawler here. Okay, refresh it. Now my requirement is if everything would be fine, I should be getting a table change count as 1. I want to see the definition of the table. And when the definition would be ready, I will be going to Athena. I am going to point to the table and will be executing the queries there. Okay. So let's wait, everybody. In the meantime, if you want to quickly check the table which you had created, this was a table and this was a mapping you had done. Order ID was of type integer, product was of type string, category was of type string, and so on. You had defined this here. Okay, this mapping you had done with the data fields. Now come back and check the status of our crawler. Can you see? One table created. In the table change column, you are getting this. And how can you check? Go to database, go to DemoDB. It will be showing you two tables. This was a one which you had created, okay, by yourself. And this is a one which got created just now. So it has used a classifier called CSV. So open this table, everybody. And this is the definition of the table. Okay. So using a CSV classifier, the table definition got created here. You can compare if you want. This was the one you had created. And this is one Glue has created for you. Okay. So now one thing you have got an idea upon. If you don't want to write a query, you can make use of Glue crawler for this activity. Okay. And now the best part is, if I am taking you back, everybody, in the Athena, this time, if you are going to use this refresh, okay, you can see you have two tables. And the best way is, if you're going to preview the table, you can see these are the records present in a table. Now, obviously, if you have to execute more queries like we had done in the past, you can. So let me help you out with some of the queries. Let's say if you have to view the unique categories, you can execute one such query here and run this. Let's see the result. This is a result, everybody. Okay. In a similar manner, you have many more queries you can execute, counting the total records, data aggregation, okay, and all. So this was my second part where I just wanted to give you the exposure. If you don't want to write the table manually, if you don't want to prepare a create table query, you can go to Glue and you can explore this Glue crawler feature. I hope you had got an understanding and it was interactive for you. Now, I am not done yet because I like to share as many info with my candidates. And for that, I have taken one more thing for all of you. What is that? This time, I want to deal with a problem. What is a problem? The problem is, let's suppose if I have many attributes as a part of my data set, hundreds of attributes or more attributes, okay, and I want to get the table definition, I want to get the column definition, or I can say that I want to get a query, create table query using code, using program. How can I do that? Okay, so for that I will be using this taxi zone lookup CSV file. Okay, I'm going to upload this file to my S3 bucket. It is having these attributes. We can have many. If you recall, I had shown you a New York taxi data set website. From there, you can download the sample data set even with more attributes. Okay. And I am going to help you out with a program. We will be using a Jupyter notebook we had used before also. So again, we're going to use. Okay. So this is the first command if you don't have these libraries and dependencies installed. We are going to make use of Pandas for it. Okay. So before that, go back, go to your S3 dashboard. I am going to upload the data set, the one I was talking about. So let me provide a folder name. Let's say New York taxi dataset, something like this. Okay, if you want, you can. Otherwise, you can directly store the data in the S3 bucket. Okay, I have explained you how you can create a prefix. Okay, let's say create this prefix. And inside this prefix, you can upload the data. So, either you can do a drag and drop or either you can upload the data directly here by clicking on add files. Okay, so let me do a drag and drop. I'm going to my folder where my data set is present. So this is a data set I'm talking about. Let's drag it and drop it. Okay, and you are going to click on upload button. So as soon as you're going to get a message, upload succeeded, this data set is present here. Okay. Now all of you know how to start a Jupyter notebook. So open the command prompt. Let me do that. And I'm going to start the Jupyter notebook, everybody. Before starting the Jupyter notebook, I have already configured the credentials in my local machine. If you recall, we had done AWS configure in order to configure the credential. And this is required if you want to interact with AWS services programmatically, okay, using CLI, SDK, or APIs. So now I am simply going to talk about by executing a command called Jupyter Notebook. Okay, if everything would be fine, all the dependencies and libraries will be present on my machine. I should be getting a notebook up and running on the local host. Let's wait for that. So you can see the outputs, and soon I will be getting the notebook up and running on my local host. And here you can see I'm getting this particular Jupyter notebook running. Okay, you can create a new notebook, everybody. Let's go to file. Let's create a file. You're going to create a new notebook, everyone. So create new notebook. Now your credentials should be having enough permissions in order to perform the actions. For example, if you want to interact with S3 using this notebook, your credentials should be having permissions to interact with S3. Okay. For a demo purpose, if you want, you can also give the administrator access. Okay. Only for the demo purpose, everybody. But please secure your credentials. Now, first thing, I'm going to test access to the S3. So let me take this particular piece and I'm going to paste it here. Okay. When I will be running this, I'm simply checking the access to S3. Okay. So this is for creating the S3 client. But if you have to get the output, let's say you want to list the bucket to verify the access, add this particular piece of code here. Okay. And now run this. Can you see? I'm able to list down the buckets in my account. It means I have the access. Okay. Second thing, I'm reading a file from S3 into Pandas. Okay. So let me take this one and I'm going to paste it here. I have to make some changes. The first change I have to make, that would be my bucket name. The second change I have to make, that would be my file key, because right now I have my file available as a part of a prefix or as a part of a folder. So first is bucket name. Let's take it here and provide this bucket name here. Everybody, do it. Next thing is I'm going to add this particular prefix here. So this is a prefix I'm adding here. Okay. So what I am doing, everybody, I'm just getting the object from S3. I'm reading the CSV into a pandas data frame, and then I am viewing the first few rows. Let's execute it. If everything would be fine, I should be getting the first few rows as the output. You can see these are the first few rows from the output. Okay. Now, what is a major thing I wanted to show you? I want to generate the Athena column definition. Okay. That is something I want to do. Okay. So let me take this particular piece, because I told you I want to do it with the help of code. Okay. So let me press enter and let me going to run this. See, I have got the column definition generated. Okay. So this is a Athena column definition. And finally, if you want to create a table statement, if you want to generate a full table creator statement, use this piece of code. Again, I have to provide a table name. Okay. I have to provide the location. You have to change the path here. Okay. And then we are writing the actual code, creating external table, and then we are going to generate the table statement. So go back, and the only change you have to do here, you have to change your bucket name. So come back and provide the location. You will be providing a bucket name in which you have stored the data, and run this. Can you see? You have got the create external table query. Okay, and this create external table query you can directly use in the Athena dashboard in order to create a table, everybody. Let's give a try. And if there would be any challenges, we are going to fix that. So let me give a try, everybody. I'm taking this create external table query and I am going to take this query in the Athena dashboard. Okay, so here I have pasted the query in the Athena editor. I have also taken another create external table query for your reference purpose. So let's see it step by step. First of all, I have to provide the exact location where my data set is present because my data set is present inside a folder. So let me provide this and let me come back, everyone. Because if you're trying to execute it before or without the exact path, what is an error? First of all, let me show you. You can see it is giving you the path can't be empty. So getting an issue with respect to a path. So if you want to troubleshoot after getting an error, that also you can do. It's a very good way to develop your debugging skills. Let me provide the exact path here. And let me now execute this particular command. So control enter. And the table got created. This New York Taxi table got created. Okay. And you have all these metadata present here. Now, if you want to preview this table, everybody, let's do that. So currently I'm not getting any data. So see, the program I have shown you is to help you out to generate or create the table definition. Obviously, you can modify or tweak your program as per the documentation. For example, I can tell you how to fix it. Let me drop this table very quickly first. Let me provide the name and let me delete it. How to deal with this error, everybody? So first thing, you have to check, have you provided the correct path or not? Yes, we have provided a correct path because my actual data set is present here. So this should not be the issue. Then what can be the next possibility of the issue which is coming here? The next possibility of the issue which is coming here, let's check the syntax, everybody. So as I told you, I have taken for your reference one of the create external table query which we had created on the sales data. Okay, let's say I am using this field delimiter field instead of this particular separate character. Okay, so let's give a try by executing this particular command and see if I'm going to get the result. So it is successful. Let me refresh it. And there is a table got created. Now let's preview the table. So we're getting the result back. So it means we can say the error was because of this field. Everybody, it was because of this field. Now next thing, if all of you had observed something, there's one more observation. It is including your result. If I will be again doing this preview table, let me show you one more time. Okay, your result is including the first record as the header, everybody. How to fix this? You know how to fix it? For that, you can alter your table and you can set the table properties to skip the first line. Let me help you out with this also. Copy this one and paste it here. Okay, you have to give your table name, which is New York Taxi table. Okay, and now execute these two queries. Let me do it once. And if I am going to execute select star this time, I will be getting a proper result back. So this is how you can fix the issues or troubleshoot the issues as a part of the Athena dashboard. So it was a good exercise, isn't it? So here what we had done, I had shown you three different ways in order to query the data present in the S3 bucket using Athena. Okay, one via Athena editor directly by creating a table, another via AWS Glue where I am using a glue crawler, and third with the help of program or a Python program where I'm writing my program, everybody. Okay, Hello everyone. So now let's talk about the next topic, that is using RDS and Redshift for structured data. The answer to this question is present in the AWS documentation. But before I'm going to take you all towards the AWS documentation, my simple question to all of you: what do you mean by structured data? So if I have to give the answer, the same answer you used to give in your school days or college days is: structured data is the one where you are storing the data in table in the form of rows and columns. Or another common definition which we used to give: the data whose schema is fixed or schema is defined. Now schema here represent a structure of your data. Okay. And yes, for the structured and relational databases, you can keep on adding more pointers, like it should be ACID compliance, it should be following the normalizations, and so many things. But what I want to show you, I will be showing you that RDS and Redshift are two major candidates of the structured data. Or you can say that these are the main candidates in the AWS managed database services whenever we are talking about relational databases. What is the difference? A very common difference between RDS and Redshift is RDS is used for OLTP, online transactional processing, and Redshift is used for OLAP, online analytical processing. Soon, as I told you, I am going to take you all to my AWS management console and we are going to perform some hands-on exercises. Okay. But before that, let me quickly take you towards the AWS documentation to show you little bit on the RDS and Redshift side. So see, you can always open the documentation in the AWS by typing, let's say, RDS AWS documentation. Okay. And you will be landing here. The first line itself, or the full form of RDS, which says that relational database service. Okay. Now, why RDS? RDS is easy to manage relational database service optimized for total cost of ownership. Now, RDS is one of the managed database service in the AWS. When we use this keyword called managed, it means most of the administrative tasks will be taken care by AWS for you. It includes operate, scale, database management tasks, let's say provisioning, configuring, backup, patching. All these things will be a part of the RDS. Okay. Or most of the administrative tasks will be taken care by the AWS for you all. Okay. If I will scroll down further, you can see the benefits of RDS. It is easy to manage. You get the choice of database engines. RDS supports different type of database engines. High availability. You can achieve high availability with a multi-AG deployment and operational expertise. These are some of the features. If you have to innovate with RDS, you can use zero ETL integration as one of the feature, and you can see the deployment option too. And these are the use cases, everybody. Now let's understand this with the help of a demo. So I'm taking you all to my AWS management console where I'm going to search for RDS. And I will be navigating to RDS dashboard, everybody. This is my RDS dashboard from where I'm going to create the databases. Okay. So click on create database. Before that, make a choice of a region because RDS is the regional service. You need to choose a specific region before creating the database instance. So from this screen, from this console, we are creating a RDS database instance. We have two radio button, one for standard create, another for easy create. Standard create means you are going to set all the configurations options, or you can customize the options, okay, in a simple way. Easy create means you are going to use the recommended best practice configurations, okay. Some configurations options can be changed after the database is created. Now these are the DB engines which RDS supports. I'm choosing MySQL. If any one of you is interested, after selecting a radio button for a specific DB engine, you can refer to the info section. Okay. So I'm selecting MySQL for my demo. Scrolling down, I am using a default engine version. If you have to use a specific version, you can choose from here. Okay. Template, obviously, as you are exploring the AWS services, so I would be suggesting you all to be a part of a free tier. But yes, if you want to create a production-based database instance, you can choose a template accordingly. Okay. I will be choosing free tier. As a part of a free tier, I don't have a multi-AG database cluster deployment or multi-AG DB instance deployment options available. Okay. What is this multi-AG? As the name is suggesting, multiple availability zones. Okay. So this is specifically used in order to provide the high availability. So here we are dealing with primary and secondary or master and standby. Okay. I will be choosing the single AGDB instance deployment because this is the only option available as a part of a free tier. Later, I have to give the DB instance identifier. Let me give, let's say I'm giving this. Okay. You can also provide the username and password. So either you can manage the username and password by yourself by choosing this self-managed option, or AWS provides you a secure way in order to store and manage your credentials that is known as a secrets manager. But for this demo, I will be using self-managed. So let me provide the password here. Okay. And in a similar manner, I'm providing the confirm password. Okay. Now, this is an instance configuration as you are creating a database server. Okay. So choose a default one or keep the default instance selected. Under storage also, I'm keeping the default setting. In the connectivity part, like how you are going to connect to this RDS database instance, I would be using EC2 instance for my demo in order to connect to the RDS database instance. Okay. If you want to use any terminal, you can use a terminal, but you have to install the MySQL client. Okay. Or if you directly want to use a graphical user interface, here you have MySQL workbench, everybody, which you can make use of. Okay. But for this demo, I will be showing you EC2 as well as MySQL workbench. Now, as per the rules, as per the ideal situation, your database should be private. Means you don't have to expose database to the public endpoint or public. But obviously, that is a part of the network setup. Means an architect will be helping you out in order to create the partitions and all. So for the time being, I am keeping all the configurations as default. Okay, default network, default firewall, and for the demo purpose, I will be allowing the public access. Remember, this is only for the demo purpose. Okay. Now, one thing all of you have to remember, in AWS, there is a concept of security group which act as a firewall. Okay. So this firewall decides what type of traffic is allowed. So I'm choosing a default security group, but in a default security group also you have to make a change if you have not done it yet. Or if you are using this dashboard, if you are using the default security group for the first time, yes, you have to make a change. What change you have to make, I will be guiding you. Okay. Rest all options I'm going to keep default. You can explore additional configuration. The database port is 3306. And then here, finally, you can explore other things like database options, DB parameter group, and many more. Now you can create the database, initial database from here also if you want. Or otherwise, you can connect to your database instance and then create a database. What is a dataset? I'm going to use everybody. So see here. These are the tables I would be creating in the RDS customers and order table, and then I'm going to insert the sample data. This demo I'm showing you in order to help you out that how RDS is used for online transactional processing. Okay. So let's say I'm giving a name to my DB called demo DB, everybody. Okay, so I will be showing you when I'm going to connect to this database instance, this demo DB would automatically be present because it will be created at the time of launching. Okay, rest all options I'm keeping default again and creating a database. So once I'll click on create database, at the top you can see a progress bar which is saying your database might take a few minutes to launch. Okay, So I have to wait for the database to be available. In the meantime, my database is getting available. I will be launching one EC2 instance, which I will be using later to connect to this RDS DB instance. So search for EC2 in the search bar and navigate to EC2 dashboard. Within this EC2 dashboard, I am going to launch a fresh instance. Okay. So it is simple. Click on launch instance. I'm going to give a name. Let's say demo server, something like this. Okay. AMI, I'm choosing Ubuntu, a Linux based operating system I'm choosing here. Okay. Instance type is again talks about the server specification. So I am keeping this default, which is t3.micro. Okay. Ensure again, if you are a part of a free tier, then you should be seeing this free tier eligibility here. Okay. Key pair is used if you have to connect to this EC2 instance using remote. Okay. So I'm choosing proceed without a key pair. And again, network setting is default. I only have to allow SSH traffic from anywhere. With all other default settings again, click on launch instance. So the instance will be launched. Wait for the instance to come up and running. And as soon as it comes up and running, I have to click on connect button and say connect. So wait for the connection to be established. And once the connection is established, I am going to check the first thing, that is my SQL version. Because a very simple thing, you will be needing a software, you will be needing a client on your machine to connect to the MySQL database. Okay. So I am typing clear to clear all the info here. And first thing I'm checking MySQL version. It is saying not found, but you can install it using these commands. So let's say sudo apt install MySQL client core 8.0. So now you can see here, everybody, I'm not asking you to learn or memorize the command. They have automatically given you. If it is not present, then use this command. Enter. It is saying that could not find any package. Okay, let me see if I have typed the correct package. No, I haven't typed the correct package. There is no hyphen between my and SQL. Now this time it's not complaining. It is doing the installation. And once the installation is done, again I can check. This time I have my SQL version. It is returning back to me. Okay. What is the next step, everybody? We have to go to our database instance and we have to wait for it to be available. So you can refresh it. Otherwise, you can refresh from the top to check the status of this database. And once it will come to the available state, I am going to execute a command. Okay. So let me open this. I have to take certain properties. So once the database would be available, certain properties would be created. Okay. So let's wait for the DB to be available and then we'll be back and going to connect again in order to show you further the importance of RDS as a relational database service. Okay, so my RDS database instance is now available. Okay, so what we have to do, let's connect this database instance using EC2. So go back to EC2 and we are going to type a command called mysql-h. -h stands for host name. So how we are going to take the host name, everybody? Go back to your database instance, open this, and this is a endpoint, or you can say this is a host name. Take it, paste it here. Then you have to type -p. -p is for port number, which is 3306. If you have to verify, you can verify from here. Okay. Then -u, it is for username. It is the same username you had given at the time of launching the database instance. Again, if you don't recall it, go to configuration. In the configuration, you can see this is a username. And finally, -p for password. So press enter. It will be giving you a prompt to type password. Keep on typing and then press enter, everybody. So if everything is fine, you will be getting a MySQL prompt here. MySQL prompt means you're connected to the RDS database instance. So this is connection via terminal. You can also connect via graphical user interface. I'll be showing you. But before that, remember, if you are coming to these dashboards for the first time, after creating a database instance with the default settings, remember one more thing, everybody. And what's that? If you will be going to connectivity and security, I had used a default security group. Open this security group, everybody. And once you will open the security group, what you have to ensure? You have to ensure one rule here. What's that? Go to inbound rule, say edit inbound rule, and don't forget to add this second rule. Allow all the traffic from anywhere. This is how you choose anywhere. Okay, and save the rules. I already have this rule added, so I don't have to save the rule. In short, this particular security group rule is allowing traffic coming from anywhere on your RDS database instance. Okay, say cancel and come back. Obviously, when you will be performing this demo, watch this video recording and follow the steps accordingly. Come back here. The first thing I will be saying, show databases. Okay, and these are the databases. Can you see? This demo underscore DB was the one which we had created at the time of launching our RDS database instance. Let's use this demo underscore DB. Okay, simple SQL queries I'm executing. If I will be saying show tables, currently there is no table. Let me create two tables. One is this customer table I'm creating. Let me create it. Okay, another is this order table. Press enter. If you will be saying show tables this time, you'll be getting two tables, customers and orders. Now you can execute the queries. For example, you can insert the sample data, because right now if you're going to say select star from orders, you'll be getting nothing here. Or in a similar manner, select star from customers, nothing present. Okay, so insert the data like I'm doing in customers. In a similar manner, insert the data into orders. Okay, and then execute the select commands. Let's say select star from orders. Okay, select star from customers, like this. So you can see the result back. In a similar manner, you can query the data by executing different command. Let's say if you have to fetch all the orders for a specific customer, you can execute this query. Here you are performing the join. Okay, you can see the result back. And the last one, I have taken total sales per customer completed orders only. Let me execute this and you can see the result back. So idea is, everybody, like here we have to understand, whenever we are talking about RDS, it is a relational database service. Okay, now next thing what I want to show you, in a similar manner you can connect it using graphical user interface. How? Click on this plus icon. This is my SQL workbench. Just provide a connection name, anything. It's just a logical name. So I'm giving a name called RDS con. In the host name, obviously you have to provide a host name. Host name is an endpoint. Take it and paste it here. Okay. Username would be MySQL 2025 and password will also be MySQL 2025 or any other password which you have given, obviously. Okay. Set test connection. You can see successfully made the MySQL connection. How? For the demo purpose, I had made my database instance publicly accessible. Say OK and OK again. Okay. And this time, if you're going to do a double click, you will be seeing a demo DB. Inside demo DB, you are going to see the tables you have created. Okay. So here also, if you will be executing this command, let's say you're using demo DB, let's execute this command. And then if you're going to select star from customers, you can see the result. Okay, so you can execute your queries here too. So choice is yours. I have given you the exposure how RDS can be used as a relational database service for structured data, where you are storing your data in a tabular form in the form of rows and columns. And I have also shown you how you can connect to the RDS database instance. Thank you very much. Okay, so now understand Redshift and explore how can we use Redshift for the OLAP solutions. So you can power data-driven decisions with the best performance cloud data warehouse. If you want to get through the features of Redshift, obviously you can go through this documentation. Okay, Redshift uses SQL. You can break through data silos and gain real-time and predictive insights on all your data in a few clicks. Okay, so what I will be showing you how to load the data from the S3 to Redshift. Let's quickly see that. So for that, go back to your AWS management console and you have to search Redshift in the search bar. Let's quickly navigate to Redshift dashboard. And to start this demo, we will be creating a Redshift warehouse cluster. Okay, what exactly we are going to do, if I'm going to show you with the help of an architecture diagram, everybody. So actually, we are copying the data from S3 to Redshift. So in a very simple way, let's say we have a S3 bucket. Let's take any of the bucket here. You can also take bucket with objects if you want. Okay, and we have a Redshift warehouse cluster. So what we are planning to do, we are planning to execute the copy command from S3 to Redshift, everybody. And then we are going to perform some analysis. Let me help you out. So we are going to execute the copy command as I told you. So without any further delay, let's move back to our AWS management console. And as I told you, we are going to start with creating the Redshift cluster or provision cluster. So go back to Redshift, expand these three lines and click on provision cluster dashboard. Okay. Create a cluster. If you don't have any cluster, you can create a new cluster. I will be taking you through this page and we are quickly going to create a cluster. Just give a name. Let's say Redshift cluster demo. Okay. You can choose the node type. Node type is talking about a specification of your cluster, which is a group of servers. Okay. So let's say I'm choosing this array3.large. Number of nodes means number of servers, which I'm choosing 1. It can range from 1 to 16 as all of you can see here. Scrolling down further, if you want to load the sample data, you can, but this time I am going to copy the data from S3 to Redshift. Okay. When it comes to database configuration, you can provide the username. You can provide the password. Again, they have given you different radio buttons. Like, do you want to manually add the admin password? Do you want to generate a password or do you want to manage the credentials in the secret manager? Let me manually add the admin password. So I am giving a password here, which I will be using to connect to my Redshift cluster. Okay. Later in the permission, I have to give one permission. How can I give the permission? I can create an IAM role. Okay. Let me show you. Let's create an IAM role, everybody. I'm going to select access type for S3 bucket. If you want to give the read access, you can select read access. If you want to give the full access, you can give us the full access. Specify the S3 bucket for the IAM role to access. So either you can say any S3 bucket, okay, or you can say specific S3 bucket. If you have to provide the role to a specific S3 bucket, you can provide a specific S3 bucket. If you say no additional S3 bucket, it will be creating the IAM role without specifying S3 bucket. So either you can create a role first, then you can refer that role in the Redshift cluster dashboard, or you can create the role from here too. Also, you can attach the role later once your Redshift cluster would be available. So for example, I'm saying any S3 bucket for the time being. Okay. Say create IAM role as default. Obviously, you can change this role. It is saying an error occurred when creating the IAM role. Make sure that your identity has the privilege to create the IAM role. Okay. So in order to deal with this error, what we will be doing, we are going to create a role and we are going to attach the role here. Let me quickly check if I can use a refresh button here. Okay. So I'm going to IAM and let me show you creating a role, everybody. So go back to IAM dashboard, and from the left hand side, we are going to choose roles here. Let's create a role. The first thing you have to choose AWS service for which you're planning to create a role. So Redshift is a service. I'm choosing Redshift customizable as a radio button. Let's say I'm providing S3 read access. Go to next. Give a role name. Exploring Redshift demo role. Okay. And say create role. This role is created. Now this is a role we are going to use, everybody. Okay. So let's see if we can associate the role. Click on associate IAM role and let's search for the role you have created just now. Okay. You have to refresh the dashboard in order to see this role into picture. Okay. So one thing, if you're going to refresh, do a browser refresh, then all these configurations would be reset. Okay. So better, but I will be showing you once my Redshift cluster would be available, we will be associating the same IAM role. Okay. I am keeping the additional configurations as it is. I'm not changing the additional configuration for the time being and creating a cluster. So let's wait for this Redshift cluster to be created. I have to wait for the cluster to be available, everybody. So, in AWS, it is very easy to create a warehouse cluster and then perform the analysis on the historical aggregated data. So in the meantime, I'm going to help you out. We will be creating a table called order analytics. We are going to load the data from S3. Okay, obviously you have to change the role, ARN, you have to change this particular bucket name. Okay, and then you're going to perform some analysis like total sales by month, top customers by total spending, order by status. Okay, and this is my sample CSV file. Obviously, you can have a small data set or you can have a huge data set. Okay, but quickly I'm doing, everybody. In the meantime, my cluster is coming into available state. Let me create a S3 bucket very quickly. So go to S3 and create S3 bucket, everyone. So click on create bucket. Give a bucket name. Let's say demo. Exploring Redshift bucket. Okay. Let's see if it is allowing me to create this bucket. Otherwise, I'm going to append the date to make it unique. Click on create bucket. This bucket got created. So very quickly, I am going to upload the data. So either you can do a drag and drop. Let me do it. Let's go back here. And this is my data set, my retail data.csv. Drag it and go back. Okay, let me just check that. Let me take this URL and say add files. Okay, and quickly select the data set. So this is a data set, everybody. Say upload. This data set got uploaded. Come back to your cluster and check the status. It is available. Okay. So you can associate the IAM role. How can you associate? I can guide you. Once your database would be available, you can explore different sections if you want, like cluster details. If you have to go to integrations, you can see we have all these integrations. Okay. You can go to resource policies. Okay. And if you want, you can explore other sections too. Let's say properties. Okay. These are the properties. Under properties, you have this associated IAM role. So let's say associate IAM role, everybody. And this time, search for the role you had created. Come back here. Okay. Select it. Associate IAM role. So this role is associated. Soon this particular Redshift cluster will come into available state. It is modifying due to the changes you have made. And very quickly, what we are going to do, let's edit our query. What would be our query? In our query, we have to provide the path of this particular data set. So use this copy S3 URI. And here in the load query, we are going to say from this particular path. Next thing, we have to ensure we have provided the correct ARN of IAM role. Let's do that. So go to IAM role, take this ARN and paste this ARN here. Okay. Come back again and check the status. Is it available or not? Let's refresh the browser in order to understand if your Redshift cluster is available after the modifications you have made. Yes, it is available. So without any further delay, let's use Query Editor version 2 to connect to your Redshift cluster. So using this Query Editor, I'm going to connect. Okay. So see, if you're coming here for the first time again, you can say added connection. It will be giving you this pop-up. Means at the starting, it can give you this pop-up. You have to choose a username and password, and then you have to provide a username and password, everybody. Okay. So let me expand this. If you want to see what is inside this Redshift cluster demo, this is our default database. This is our default schema. Okay. Inside this, we can have tables. Okay. So currently I have a 0 tables because I had not loaded any sample data. So let's create a table, everybody. It's a create table query. I'm going to select it and execute it. Okay. So you can see you have got a success result. And how can you verify? Let's expand this and let's see if any table got created. So yes, we have one table got created, everybody. Okay. And this is the order analytics. So currently, if I will be doing select star from order analytics, okay, and I am going to execute this query. Let me do it. I'm not getting anything, or it is giving me order analytics does not exist. Okay, it is orders actually. Let me execute again and let's see the result. If I'm going to get a result back, I'm getting the empty table. Okay, let's say if I have to load the data from S3, this is a command I'm going to use. Copy orders analytics from this particular path where my retail data.csv is present. This is a role for authentication, and I am passing the additional attribute called CSV and ignore header 1. The first line I want to ignore. Okay, let's execute it. And if everything would be fine, you will be able to see that data will be loaded from S3 to Redshift. If there will be any issue, we are going to troubleshoot the issue, everybody. So let's see what is the result we're going to get. Okay. It is saying 5 records loaded successfully. And how can we check it? Again, execute the select query. Can you see the data, everybody? This is the data inside my Redshift, which I have loaded from S3. Okay. Now, if you want to execute the analytics query, everyone, you can execute analytics query. Let's say total sales by month. This is my first query I'm going to execute. And let's see the result here. Okay. So we are going to execute this query and quickly see the result. What is the result we will be getting from this query? So we are getting month and total sales. So total sales by month. This was our query. Okay. In a similar manner, I can say total customers by total spending. Okay. So you are analyzing your data. You can also aggregate petabyte scale historical data here, and later you can run the analysis on top of it. Okay. One more power of Redshift is you can build the dashboard on top of the data present in the Redshift. It is a business intelligence service too. Okay. And finally, if you have to get the order by status, you can execute this query. And let's see the result we are going to get. Okay. So in a similar manner, if you want to execute more queries, you can in order to get the result back. So idea is I wanted to help you out how Redshift is used as a structured database service. But yes, with the advanced features of Redshift, even if you're going to go through the documentation, Redshift also supports the semi-structured data. Okay. And we had seen how can you load the data from S3 to Redshift. So let's keep this part till here. Thank you very much.